In this class, we're going to take a look at inverse functions, and inverse in this sense just means reverse or opposite. So whereas a function acts upon a variable in a certain direction, the inverse acts in the opposite direction. So a good way we can visualize this, if this is a domain of a function represented by this little, circly thing. So let's say that's the domain. And then we've got the range of a function, which is all the kind of output values. So we could actually call this the input values, and these are the output values. If you're not familiar with domain and range, don't worry about it too much. So a function basically is this kind of mapping thing. It takes a number from the domain and it gives you a number, an output value in the range. So we would call this f to represent the function. The inverse function goes the other way. It maps from the range back to the domain, and we call that f to the -1. So the inverse of f. So to put an actual example up, so let's say that our function f of x is some simple function like 4x. That takes your x value and multiplies it by 4. So if we took the number 3 in our domain, running that number through the function f, that would be f of 3, which is 4 times 3, that's going to give you 12. If you then take that number and apply the inverse to it, f to the -1, that needs to be such that it takes you back to 3, okay? So the mapping f takes you this way, the function, and the inverse function, the reverse mapping, takes you back going this way. So that guy was going this way, and this guy was going that way. So if we look at that function and think about what it does, it takes the x value and it multiplies it by 4. That's the operation. Take it, multiply by 4, quite simple. The opposite of that is clearly take the x or the input value and divide by 4. That's clearly the opposite operation of multiplying by 4. And we can see that dividing 12 by 4 would take us back to 3. So in that case, our inverse function, f to the -1 of x, we can just figure that out just by looking at the function. Okay, there's nothing to do algebraically. We just say, hey, that guy says multiply by 4, so the opposite must be divide by 4. And that is essentially how inverse functions work. If you know the function, you can work out the inverse. However, as the functions get more complicated, you're not just necessarily going to be able to look at the function and say, hey, it's just as simple as dividing by 4. So we need an algebraic process to go through step by step to figure out those inverse functions. But that's a kind of conceptualization of what we're looking at. Let's take a look at these 3 examples I've got here. If the function's not terribly difficult, like this one, you can look at it and at least get an impression for what the inverse is going to be. Sometimes you can look at it and just figure the inverse out. So what's going on here? Well, the x is being multiplied by 5. We're then subtracting 1. So there's 3 things going on there. There's the multiplying by 5, there's the subtracting 1, and then there's also the order. There's the order which is multiply by 5 first, and then subtract 1. So when we come to do our inverse, not only are the operations the opposite, in other words, the multiply by 5 becomes a divide by 5, the -1 becomes a +1, but also the order in which those are applied gets flipped around. So when we work our inverse out, let's just go back at the end and check that it makes sense in terms of that intuitive idea of what the inverse should be. So the way we do this is we start by changing the function notation to a letter like y. And that's just because we're going to do some algebra here, and we tend to not use function notation when we're doing algebra. So we're just changing that to y. All we then do to find the inverse is change the subject of the formula to x. Because if you think about it, the inverse is replacing what the function is, reversing what the function is doing, going from an x to a y value by making it a y to an x value. So you're basically just swapping around the variables. To rearrange that one is fairly straightforward in terms of the algebra. So you would get 5x equals y plus 1, and then just dividing by 5, y plus 1 over 5. What we do at the end is we go back, and because it was an f function, we rewrite it as f to the -1 of x, and we just replace the y back with the letter x to make it consistent. So we get x plus 1 divided by 5. So this guy here says take your x, multiply by 5, take away 1. This guy here says take your x, add on 1, and then divide by 5. So even just by looking at what you've started with and what you've ended up with, you can see that they are opposites of each other. That's how it should be. As they get more difficult, it might not always be obvious to make that link, but it should still roughly look like you're just intuitively changing around the operations and the order. So let's do the same thing with this guy. Sometimes with a negative here, it's a little more difficult. I mean, negative and then the variable, because it's a little more difficult to see intuitively what it comes out to be. So we'll just run through the algebra and see what we get. So changing the g of x to a y, and we're going to change the subject of the formula now to x. So it comes out looking like this. Just make a little space here, x cubed plus 9. Okay, so we've got it so rearranged. That should of course be a 5, and then we can just go and write the inverse. G to the minus 1 of x equals 7 minus x over 5. So a little more difficult, these ones in general, to kind of make the intuitive leap, but you can see that you've sort of got the same things going on there. They always come out a little differently, these ones, but you can at least see that divided by 5 is consistent there. You just got to trust the algebra a bit more with one like that. Okay, checking out that example I had, I can't remember what the letter was. Let's say it was h of x, so x cubed plus 9. These can really look like anything. As they get more difficult, the algebra might be more complicated to sort out, but it's just going to be more algebra. There's nothing really changing in the process. So we're going to change the h of x to y, and then it's just a case again of rearranging the equation to x. So we would get x cubed equals y minus 9, and then we're just going to take the cube root, so cube root of y minus 9. And just going to take one more line to rewrite that in the correct notation. So I'm just going to pull that guy up to here. So h to the minus 1 of x is going to equal cube root of x minus 9. So cube root x minus 9. That one you can see a little more clearly as a connection to the original. The original function says take your x and cube it and add on 9. This guy says take your x, take away 9, and then take the cube root. So that one has almost got an immediate intuitive reverse operation to the original function. So inverse functions are not particularly difficult. It's really just an algebraic exercise. Once you've learnt the very simple process of changing the function notation to some other variable, it doesn't have to be y, we tend to use y, then just switching the formula around to get it subjected to the other letter in the question, that is, you basically found your inverse. Don't overthink it, there's nothing much more beyond that. Just spend a little time practicing these, in particular practice in different formats. The more experience you've got with different types of function in different formats, the more comfortable you'll be with these when you see them on a test or on an exam.